Hi students, so welcome you all again. In this video, I am going to continue our previous chapter, that is vectors. In the previous class, we have already discussed some of the problems on vectors chapter. So today we shall continue with the vectors chapter from where we have left in the last class. Okay, so in the last class we have seen these two observations, and we have also seen this third and fourth observation. We have solved example 13 and we have solved example 14. Clear? So today we shall continue with example 15. Clear? So in this example, let us see what they are asking to solve us. Clear? So in the example 15, if vector A equal to 5 I cap minus j cap minus 3 k cap and vector B equal to I cap plus 3 j cap minus 5 k cap, then show that the vectors vector A plus B and vector A minus B are perpendicular to each other. Clear? Okay. So here vector A and vector B are given. Then show that vector A plus B and vector A minus B are perpendicular to each other. In this case, first we have to solve vector A plus vector B, and then we have to solve vector A minus vector B. So first we have to calculate vector A plus vector B and vector A minus vector B. Then we can see the further calculations how to show vector A plus vector B is perpendicular to vector A minus vector B. So here we know that two non-zero vectors are perpendicular if their scalar product is 0. We know that two non-zero vectors are perpendicular if their scalar product is 0. So no problem, let us solve the scalar product. Before that, first I will calculate vector A plus vector B. So you have to add I cap and I cap. See here, 5 I cap plus I cap is 6 I cap minus j cap plus of plus 2 j, minus j cap plus of plus 3 j cap. So that is plus 3 j cap minus j cap will be plus 2 j cap minus 3 k cap minus 5 k cap will be minus 8 k cap. Clear? So this is vector A plus vector B. On the same way, we have to calculate vector A minus vector B. So that is 5 I cap minus I cap is 4 I cap minus j cap, minus into plus is minus. So minus 3 j cap is, it will be minus 4 j cap. That means minus j cap minus 3 j cap. So this will be minus 4 j cap. This is minus 3 k cap minus into minus plus. So that is minus 3 k cap. Here minus into minus plus 5 k cap. So this will be what? Plus 2 k cap. Clear? So they have calculated A plus B and A minus B. So now using A plus B and A minus B, we have to calculate these two vectors are perpendicular or not. That means vector A plus B and vector A minus B are perpendicular to each other or not, we have to calculate. So for that we have to calculate the scalar product. We have to calculate the scalar product. So how to calculate the scalar product? Vector A plus B dot vector A minus B. So write vector A plus B, write vector A minus B. So please remember one formula, that is A1 into A2 plus B1 into B2 plus C1 into C2. This is scalar product. So this is scalar product. This I have already discussed in the previous classes. You can go and watch on my YouTube videos, no problem. So here A1 into A2. A1 value is 6 I cap, A2 value is 4 I cap. So if I make a dot product of 6 I cap and 4 I cap, 6 into 4 is 24, I cap dot I cap is 1, so 6 into 4 will be 24. Next, 2 J cap, that is plus 2 J cap minus 4 J cap. J cap dot J cap is 1, plus 2 into minus 4 is minus 8. Next, minus 8k cap plus 2k cap. 8 into 2 is 16. So minus into plus is minus. So minus 16. So if you simplify this, you are going to get 0. This is 24 minus 8 minus 6. That means minus 24. If I simplify this, it will be equal to 0. Therefore, dot product is 0. If dot product is 0, both the vectors are perpendicular to each other. That means vector A plus vector B and vector A minus vector B are perpendicular to each other. Clear, students? So this was a very simple problem, but you have to understand it. For that, you must remember one formula, that is A1 into A2 plus B1 into B2 plus C1 into C2 must be equal to 0. That means scalar product must be equal to 0. If the scalar product is 0, then it is going to show that vector A plus vector B and vector A minus vector B are perpendicular to each other. Okay. Now let us go for the next problem. Okay. What they are asking here? Find the projection of the vector. Find the projection of the vector A on the vector B. So you can see in the observations, I have given the formula for the projection of vector A on vector B. Vector A on vector B is equal to vector A dot B cap. Vector A dot B cap. If you see the observations of the projection of two vectors, you are going to see this formula which I have already explained. So this formula I am going to use in this particular problem. Clear? Okay. So first, the projection of vector A on vector B is given by, see this formula. This is nothing but vector A dot B cap. See here, this is B cap equal to vector B divided by mod of vector B, that they have used here, and A is made a dot product with B cap. That means vector A dot vector B divided by mod of vector B. Clear? So that is they are going to calculate here. A dot B means again A1 into A2 plus B1 into B2 plus C1 into C2. So here A1 value is 2, B1 value is 3, C1 value is 2. A2 value is 1, B2 value is 2, C2 value is 1. So they are calculating A1 into A2. That means 2 into 1. Next, plus B1 into B2. That is 3 into 2. Plus C1, that is 2 into 1. C1 into C2. Clear? So 2 into 1 plus 3 into 2 plus 2 into 1. Therefore, this is divided by square root of vector B means what? Square root of vector B is equal to square root of x square plus y square plus z square. That means 1 square. This is 2 square plus here it is again 1 square. So this will be 1 square plus 2 square plus 1 square, that is root 6. Therefore 5 divided by 3 into root 6 will be the answer for your problem number 16. Clear? Okay, now let us go for the 17th problem. In the 17th problem, see there, find magnitude of vector A, find magnitude of vector A minus vector B. That means you have to calculate mod of vector A. So you have to find mod of vector A minus vector B if two vectors, vector A and vector B, are such that mod of vector A equal to 2, mod of vector B equal to 3 and vector A dot vector B equal to 4. Clear? That means they are asking to find magnitude of vector A minus vector B. Okay. So what is given here? See, they have said to find magnitude of, so magnitude of vector A minus vector B whole square. Mod of vector A minus vector B whole square is nothing but vector A minus vector B into vector A minus vector B. Clear? As you all know, vector A dot vector A is equal to what? Mod of vector A square. Vector B dot vector B is equal to what? Mod of vector B square. So this results we are going to use here. What they are telling? Mod of vector A minus vector B is equal whole square is equal to, they are multiplying vector A minus vector B dot vector A minus vector B. Clear? So vector A minus B dot vector A minus vector B is nothing but what? Mod of vector A minus vector B whole square. Clear? So if I make dot product here, vector A dot vector A dot minus vector B minus vector B dot vector A minus vector B dot minus vector B. So it will be plus vector B dot vector B minus vector B dot vector A minus vector A dot vector B vector A dot vector A. So here this term is mod of vector A square minus of 2 times of vector A dot vector B plus mod of vector B square. Clear? Okay. See here. Mod of vector A square, that is vector A dot vector B. This term is minus 2 times of vector A dot vector B plus vector B dot vector B is mod of vector B square. So now you are going to have mod of vector A as 2. So in the place of mod of vector A you write 2 square. You have mod of vector B, in the place of mod of vector B you write 3, that is 3 square. They also given vector A dot vector B. So in the place of vector A dot vector B you write 4. Clear? So 2 square is 4. Minus 2 into 4 is 8, 3 square is 9, 4 plus 9, 13, 13 minus 8, 13 minus 8 is 5, clear? So that is magnitude of vector A minus vector B equal to 5, magnitude of vector A minus vector B whole square is equal to 5. If I apply square root on both sides, it will be mod of vector A minus vector B is equal to root 5. Okay. See this. Magnitude of vector A minus vector B whole square. Magnitude of vector A minus vector B whole square is equal to 5. If I make square root on both sides, it will be mod of vector A minus vector B equal to root 5. Clear, students? Okay.